How do you build an artificial brain from scratch? Get ready to follow the incredible journey of how an AI like GPT-5 actually comes to life.
Part 1. Building the brain, the foundational model. Let's start at the very beginning with boxes 1 and 2. First, in step 1, data collection and curation. Imagine building the biggest, most diverse library in the world. But this library doesn't just have books, it has everything. The entirety of the public internet, academic papers, news articles, song lyrics, and programming code. This is the material the AI will learn from. Next, in step 2, unsupervised pre-training. We unleash our baby AI into this giant library. We just give it one goal: predict the next word or the next pixel in an image. This is unsupervised because no human is teaching it this is right, this is wrong. By simply predicting what comes next over and over again on trillions of data points, it starts to learn the patterns of language, the rules of grammar, facts about the world, and even concepts of logic and reasoning. The result of this stage is the foundational model. Think of it as a genius who has read every book in the world but has no social skills. It's incredibly knowledgeable, but unrefined and not yet particularly helpful or safe. Now we enter the fine-tuning pipeline. This is where we take our raw genius model and teach it how to interact with people and be useful. This starts with step 3, supervised fine-tuning. Supervised is the opposite of the last stage. Here, humans get directly involved. We create a high-quality instruction manual of sorts, made of thousands of question and answer pairs. A human expert might write a question like, explain gravity to a 5-year-old, and then write a perfect, helpful, and safe answer. The model studies these perfect examples to learn the style of being a helpful assistant. Next, we move to step 4, reinforcement learning from human feedback, RLHF. This is all about teaching the model our preferences. Human reviewers rank different model answers from best to worst. This feedback acts like a reward system, teaching the model what kinds of answers humans find better, more helpful, or more creative. It's like training a puppy with treats. It gradually learns what you want it to do. It's in these human-led stages where biases can creep in. The data created and the preferences given by human reviewers reflect their own cultural backgrounds. This is why a model might be fantastic at understanding English, but struggle with a smaller language like Estonian. There are simply far more English-speaking reviewers providing that crucial feedback. And notice the arrows looping back from steps 5 and 6. This process is iterative. We constantly test the model, evaluation, have experts try to trick it, red teaming, and even use AI to generate new training data to patch its weaknesses. This loop of tuning, testing, and fixing happens over and over again. At the end of this pipeline, we have the polished, powerful GPT-5 model. So we have the amazing GPT-5, but there's a problem. It's huge. Running it is expensive and slow, like using a supercomputer to do simple math. This is where the distillation pipeline comes in. In step 7, distillation, we use the big, smart GPT-5 model to teach smaller, more efficient models. Imagine the master chef, GPT-5, teaching its apprentices, GPT-5 Mini and GPT-5 Nano. They learn by watching the master. The final result isn't quite as good as the master chef's, but it's still fantastic and way faster and cheaper. GPT-5 is the powerhouse for the most complex tasks. GPT-5 Mini is the versatile all-arounder, great for most everyday queries. GPT-5 Nano is the speedster, perfect for simple, quick tasks. These smaller models then go through their own specialized training in step 8. So now we have a whole family of models. How does the system know which one to use for your request? That's the job of the router. Think of the router as a smart dispatcher. When your prompt comes in, the router quickly analyzes it and decides which model is best suited for the job. We'll talk more about this in a moment. Finally, in step 9, deployment and continuous improvement, the model is released, but the work never stops. The developers are constantly monitoring it and using that data to make the next version even better. So, how does all this technology feel when you're the one asking the questions? Let's look at what happens on your screen. A. Think deeper versus quick answer. You might have noticed options to ask the model for a quick answer or to think more deeply. You might assume these are two different models, but they're not. You're always talking to the same core GPT-5 brain. The difference is simply in the instructions. When you ask for a quick response, the system gives the model a quiet instruction. Be brief. Get to the point. Don't show your work. When you ask it to think deeper, the instruction changes. Take your time. Explain your reasoning step by step. Show me how you got there. During its training, the model learned how to think out loud when asked, so you're not switching to a different brain, you're just flipping a switch that tells the same brain to be either a concise expert or a detailed teacher. Now let's return to that clever router. Its job is to be a smart traffic director, instantly choosing the right model from the family, GPT-5, Mini, or Nano, for your specific request to perfectly balance speed, cost, and quality. So what influences its choice? The complexity of your question. If you ask something simple like, what is the capital of Estonia? The router knows GPT-5 Nano can handle that in a flash. But if you ask it to write a business plan for a new tech startup, it will route you to the powerful main GPT-5 model. If you specifically asked for a quick response, the router will prioritize speed and send your request to the faster Mini or Nano models. If you asked it to think deeper, it's more likely to use the main GPT-5 model. Your subscription level? Just like with many services, premium or enterprise users will more frequently get access to the most powerful GPT-5 model for their queries. Real-time system traffic. If the main GPT-5 model is experiencing very high demand, like a traffic jam on the highway, the router is smart enough to redirect some requests to GPT-5 Mini. This ensures everyone gets a reasonably fast response instead of getting stuck in traffic. So, from a single library of data to an entire family of AIs, the development of the GPT-5 family of models is a dynamic and intelligent process.
Thanks for listening. With this foundation, you're good to go.